Now, I've already pointed out that the function kind of looks like a parabola here, doesn't it? Okay, that this graph kind of looks like a parabola here, and of course this graph kind of looks like a parabola here, and also it looks kind of like a parabola here, doesn't it? Now, it doesn't stay parabola, because obviously this thing that looks like a parabola close to the 0 at x equals 3, yeah, it's plausibly parabolic on this side, although we can see that it gets way steeper than a parabola would if you go a little ways. On this side, well, yeah, it looks like a parabola from about here to here, but then it starts turning around, so it does this. Well, it doesn't look like a parabola then if you get far enough away from this point that acts like a vertex, okay? Now, let's look at the expression for the function again. I've written it out here. What's the graph of x minus 3 squared look like? Well, x minus 3 squared is a parabola with a vertex at 3, 0, isn't it? Okay? So it's starting to look like, well, maybe for some reason then, this thing does give us a parabola with a vertex at 3, 0. Well, a stronger plausibility argument, if we go just a little ways to the right or left of x equals 3, well, x minus 1 and x plus 4 won't change all that much as long as x stays close to 3. So it's as if x minus 1 times x plus 4, if x equals 3, that's going to be 2 times 7, which is 14. Okay? So if x is close to 3, these two factors will multiply out to something close to 14. So this is going to be close to the parabola 14 times x minus 3 squared, just a vertically stretched x minus 3 squared parabola. Okay, so I hope you understand that, because if you do, you have a pretty deep understanding of what goes on near a vertex. And you'll also understand what would happen if I change this square, x minus 3 squared, to a cube. What does a cube function look like near its, it doesn't have a vertex, but near the point that would correspond to the 0 of the basic cubing function? Well, at the 0 of the basic cubing function, you get this behavior, right? And you begin, maybe, I hope, to even further understand, if you understand at all, why we did right away the graphs of the basic functions and required you to know the arithmetic that's involved in evaluating those functions. You simply have to know these things in order to begin to understand what I'm talking about now. So if it was an x minus 3 cubed, well, in the first place, that would bring the behavior over here down to the negatives. So it would actually look like this at x equals 3. So if we had an x minus 3 cubed instead of squared here, we'd have a negative here. I'm sorry, near x equals 3, this would be positive. Have a positive. Well, I'm not going to worry about that. There's something that's a little worrisome in what I just said. But you still get the idea. If this was an x minus 3 cubed, you'd have a multiple of x minus 3 here. So that near x equals 3 would behave like a cubing function. So it would either be like this going up or like this going down. And you can then determine which. Actually, yeah, that was ignorant. I'm looking at this and seeing the down And then when I look at the numbers, I see that it has to be up, but now it's very clear that it has to be up, and I shouldn't let that picture, which isn't right anyway, distract me, but it did. So there's what the graph is going to look like if I replace the square now by a cube near this point.